Today's topic is retrieval augmented generation RAG with LangChain. So, have you ever wondered with why AI sometimes gives confident but wrong answer? What if your AI could actually read your own document before reply? That exactly where retrieval augmented generation or RAG comes in. In this video, we will understand what RAG is, why it is so powerful, and how to build a basic RAG system using LangChain. We will see how RAG combines document retrieval with large language model to produce accurate, fact-based, and domain-specific answers using PDF database or guidelines. And we also understand what basic requirement is required to run RAG with LangChain in your local system or cloud server. So first, basic requirements to build RAG with LangChain. So first of all, you need to require Python environment. So in this, you need to make sure in your system Python is installed, or if it is not installed, you could install Python. Okay, and download menu setup Python 3.9 and above, and virtual environment recommended. Make sure you have create virtual environment and then the other activities and steps. Second requirement है required libraries. Install essential LangChain and VectorDB package libraries by using basic command pip install LangChain, pip install LangChain community, pip install LangChain OpenAI, okay, Olma or any other AI you have used. What? Pip install ChromeDB, VectorDB, pip install PyPDF, or pip install sentence transformation. These are some basic libraries required, and any other if you use any other packages, so you can also require to install these other packages as per your requirements. If you need to store to save some information in as MySQL, so you need to install pip install and MySQL. Okay, libraries also. Third, knowledge source or document. Okay, so you make sure you have a knowledge source information whether from which you have gathered the knowledge resources or data to retrieve from. It is PDF, doc, text, web pages, or database text. Fourth is document loader. Loads document into LangChain. So make sure you need to also install document loader. From LangChain community, document loaders import PDF loader to load PDF document. Fifth, text splitter or chunking. Splits large document into small chunks. Okay, so you need to also use text splitter. Sixth, embedded model. Okay, what embedded model do? To convert text into vector, we can use option A. There are two options. One is embedded OpenAI embedded model. Second is offline local embedded model. Okay, so we can use any of them. Seventh is vector store database. So now we have used VectorDB or ChromeDB database to store embedded for fast retrieval. We have stored the embedded text into convert text into vector to vector database to retrieve frequently or fastly. Seventh, retrieval. How to retrieve chunks? Okay, so once you have stored in VectorDB, so then you can retrieve it. Fetches relevant document chunks. Language model. generate answer using retrieve content. So you can also use cloud LLM model, or also you can use offline Olma model or other models. Depend upon, you can also use local model. Install Olma in your system and they can use the local language LLM, local language model. RETRIEVAL final. So putting all the things together to get a source document answers. Basic, no, then minimum system requirement. Recommended is 16 GB, but minimum requirement is 8 GB. Storage is 10 to 20 GB. CPU 4 core or GPU optional needed for the large local LLM model. But basic minimum requirement for this to run any basic, if you need to build any basic application using RAG with LangChain. Folder structure, always a project, then document doc where you have put all the documents. If you RAGDB, then models and requirement file. So once you run it, and all other things are required. And app py and server py, others you name anything, name default we name app.py, where man rag code is type or available. To build RAG with LangChain, you need to documents, embedded vector database, a retriever, and a LLM all connected in a retrieval QA chain. So this is a basic requirement. Now, what is RAG? RAG stands for Retrieval Augmented Generation. It is a modern AI architecture that combines search, retrieval with text generation LLMs, so that AI can give accurate, up-to-date, and domain-specific answers. There is a comparison table. Comparison of normal LLM with RAG, Retrieval Augmented Generation model. The knowledge source, general training data only. With RAG, your own documents, PDF, Word, DB guidelines. Access to private data, no access. Fully access, you can access your private information, which is available in your PDF, Word, DB, and guidelines. Hallucination risk high, and this very low. It is because it is very specific data, documents, information where we have retrievable data. Answer accuracy is medium without RAG, and with RAG it is high fact base. Data freshness, no update, always up to date. Source citation not possible, it is possible. Custom domain knowledge limited is strong. Offline capability no, yes. Private server deployment not ideal, fully supported. Using government enterprise risky. With RAG it is recommended. Trust compliance without RAG is low. With RAG is high. Why LangChain for RAG? To fast development, modular design, support open AIs and local LLMs, built-in retriever and loaders, easy EPI and chatbot integration. So that's why we have used LangChain for RAG. What is LangChain? LangChain is a framework for building LLM-powered applications with modular component, pre-built modules for document loading, embedding, chain, easy integration, work with popular LLM, vector database and tools, production ready, built for scalable application. What we need to build RAG? First, we need to install LangChain, LangChain community, PYDF, LangChain Hugging Face, okay, and LangChain Grok or any other model, LLM model. Core concept, document loader, load data from various sources. Text splitting, already I have mentioned these things in previous in previous slides. Okay, again is text splitter, break down document into chunks. Embedding, convert text into vector. Vector stores, store and search embedded data. Retrieval, find relevant documents. LLM generate response, evaluation, access, performance. Document loading, what it does, convert various documents format into structured text that can be processed. Then already available loaders, PDF loader for PDF file, text loader for plain text files, web-based loader, website content, CSV loaders for CSV files, Wikipedia loader, Wikipedia articles. So simple, there's some syntax from LangChain communities, document loaders, import PDF loader for PDF. Then you say this loader, you need to just load equal to PDF loader, and you just you give the path of the document. Documents equal to loader.load, they can load document, and printf loaded land documents. You can also see this. Pre-processing, manual required. Important things. LangChain does not provide built-in processing. You must write custom code. When to pre-process, document have noise. Formatting issues, need to clean headers, footer, page numbers, want to standardize text format. So once you have once you load, you need to pre-processing this information. It is manual work. And there is a simple syntax. Def pre-processing do text, then text equal to re do sub. We can remove these things, text, page numbers, and other extra characters. Text chunking. What it does? Splits large documents into smaller pieces for better retrieval and processing. Why it is needed? Embedded model have token limits, 500 to 1024 tokens. You can also increase it, but it is more costly, so we have used default, is a standard format. Small chunks, more precious retrieval. Maintain context with overlapping chunks. How we have implement? There is simple syntax from LangChain.text splitter import. You can also find this information in Google or ChatGPT or any other. Okay, just search it, and you can also find complete code standard format. Key parameters mainly chunk size between 200 to 1000 character. 300 to 400 is optimal. Chunk overlay 10 to 20% for chunk size. Separate paragraph, sentence, words, everything, other things. Embedding is next. What it does? Convert text chunks into numerical vectors that capture semantic meanings. There is a popular model, all MPNet based V2, best balance for quality and speed. All mini LM L6 V2, fastest, good for large dataset, text embedded data 002 OpenAI high quality model, and a lot of other models are available. Vector database. What it does? It stores embedding and enables fast similarity search to find relevant chunk. YFISS fast optimized for similarly search. Scalable, handles millions of vectors. Free open source Facebook AI. Open source. Free open source Facebook AI tool. GPU support, fast processing with CUDA. How we have implement for LangChain community.vector store import FAISS. Okay, DV FAISS form document doc embedding print. Alternatives: Pinecone, managed cloud services, Chroma, simple, lightweight, quadrant, high performance option. And Okay, there is other similar databases you can use for this. Retrieval. What it does: find the most relevant documents chunks based on user query similarity. How it works: convert queries to embedding, search vector database for similar chunks, return top k most relevant result. Yeah, there is implemented syntax. Okay, so in key setting में you use to k number of chunks to retrieve 3 to 10, search type similarity or MMR for diversity, score threshold minimum similarity score. Generation. What it does: uses retrieved context to generate accurate contextual response with an LLM. How it works: combine retrieved chunks with user query, create structured prompt with context, LLM generate response based on provided context. Chain type: stuff fast limited context, map reduce handles more context, refine most thought but slow. How it does work: query context, then go to LLM and then response. How we have generated? There are simple basic uh, code. Okay, for you first initialize LLM, then create RangChain and then generate response. Evaluation. What it does: measures rack system performance to ensure quality and identify improvement. Key metrics is faithfulness, answers stay true to source document. Relevance, answers address the questions. Retrieval qualities, retrieved chunks are relevant. Okay, so there's some example, simple sample example for LangChain evaluation.qa import QA evaluation, chain evaluation. Example: query answer is a ground truth answers. Predictions is query result, response result. Evaluate eval chain for LLM graded output. That's a simple implementation. You can also checking. You can also found other relevant a lot of codes for this. Okay. Evaluation type: automated BLU, RUJ, BAT score. Human user rating, comparative analysis, continuous A/B testing or feedback loops. Key success tips: always optimization. Chunk size start with 300 character, adjust based on your data. Overlap use 50 to 100 character for context preservation. Retrieval experiment with K3 to K10 based on query complexity. Temperature keep at 0 for factual response. Common issues we everybody face whenever they can run first time to time or time this type of they can build any application other things using right with LangChain. So poor retrieval, check chunk size and embedded model. Hallucination, ensure context is relevant and sufficient. Slow response, reduce chunk size or number of retrieved dogs. Production ready में catching, make sure use catching, store frequently access embedded monitoring, track query performance and user feedback. Error handling, gracefully failure and fallback, security, protect API key and sensitive data. These are key success tips. Overall summary: in read pipeline, first document loaded, then pre-processing, then chunking, then embedding, then vector DB, retrieval, generation and evaluation. Remember, pre-processing required manual implementation. Chunk size affect retrieval quality. Evaluation is crucial for production system. Start simple, then optimize based on result. So make sure you have used one document, a small document. Okay, and then do this all, follow all those standard activities code. Okay, and run. and create any simple application, okay, with single document or two documents, and done in your local system. I hope this video is very helpful to you. This video is helpful to you. How we have used RAG with LangChain to develop any chatbot, okay, any any information gathering tool. Okay, you can also use RAG with LangChain to develop public health application to share general information with public regarding disease, okay, precautions, treatment plan, other things. You have I hope this video is helpful to you. And next upcoming videos, I have created a demo to how to install these things and run a simple code. Okay, how you have RAG with your LangChain, and other videos you can also found our previous video regarding application, how you use Google Form. Okay, and I also looking your feedback. So make sure you can please share your feedback or comment in comment box or video. So based on this, I can also create any other relevant videos or informative video to you. One last things, make sure you can subscribe my channel. So whenever I have upload new video, so you can easily get information and watch our upcoming videos and this video. Thank you.